Hello everyone, my name is Amit Kumar Singh and welcome to my class on business statistics. In this class, I'll discuss the derivation of the formula of coefficient of correlation. So if you see the formula of coefficient of correlation, probably I'm talking about Carl Pearson coefficient of correlation formula. So basically, when we talk about coefficient of correlation formula, we have Carl Pearson coefficient of correlation formula. We have Spearman rank correlation coefficient formula. We have bivariate frequency distribution formula. But here in this class, I'll restrict my discussion on Carl Pearson coefficient of correlation formula. So here I'm talking about Carl Pearson, Carl Pearson coefficient of correlation, Carl Pearson coefficient of correlation formula. So discussion on that, Carl Pearson coefficient of correlation formula. So when I talk about Carl Pearson coefficient of correlation formula, so we have two formulas. So basically, the formula number one, if I talk about formula number one, the formula number one is R of xy is equal to n summation of xy minus summation of x into summation of y. Okay, R n summation of xy minus summation of x into summation of y. Okay, divide by square root of summation of n summation of x square minus summation of x whole square, then n summation of y square minus summation of y whole square. So this is the formula. This is formula number one, and then one. Let me erase. Then the next formula of Carl Pearson coefficient of correlation. So the another formula for Carl Pearson coefficient of correlation. So the another formula of R of xy is equal to summation of x minus x bar into y minus y bar divided by square root of summation of x minus x bar whole square into summation of y minus y bar whole square. These are the two formulas of Carl Pearson coefficient of correlation. I'll talk about derivation of these two formulas. Okay, everyone. So the purpose of this class this is to discuss the formula of Carl Pearson coefficient of correlation and how to derive this formula. So formula part is one thing, and if you're really interested in statistics, you want to go into more detailed discussion to understand how this formula came. So for that, you need to understand something called covariance. You need to know the formula covariance between x and y. Suppose I want to find the coefficient of correlation between two variables called x and y. So the formula here stands that the covariance between x and y is equal to r of x and y. R means coefficient of correlation between x and y into standard deviation of x into standard deviation of y. Okay, so I believe everyone knows this is called standard deviation. This is called standard deviation. This is called standard deviation. Standard deviation is the square root of variance. So standard deviation formula is under root of summation of x square by n minus x bar square. This is one formula of standard deviation. Another formula of standard deviation is summation of x minus x bar whole square by n. By divide by n for population, or for sample you'll do divide by n minus 1. Okay, everyone. I believe till here nobody have any doubt. So this was the standard deviation formula. So basically what you need to remember is that the covariance between x and y, when we say covariance between x and y, that is equal to r of xy into standard deviation of x into standard deviation of y. Okay, everyone. So you know this formula of variance and standard deviation. You need to understand that the variance is the square of standard deviation. I hope you are aware about. So if you're watching my video on correlation, so by this time you should be very clear with the concept of measure of dispersion and measure of central tendency. So when we say what is covariance, so covariance is basically the mutual attraction or repulsion which occur between two variables whenever two variables come in picture. So whenever we think of creating portfolio in investment management, whenever we talk about finding out the risk where the two variables are present, so there is a mutual attraction or repulsion which can be present between the two variable, which is called as covariance. So that is basically is the covariance. What is coefficient of correlation? Coefficient of correlation is basically the relationship between the two variable. So whenever we talk about two independent variable and we want to establish the relation between the two variable, that we called their relation as the coefficient of correlation. So the relation between the two variable is called as coefficient of correlation. Okay, so when we say coefficient of correlation, when we talk about coefficient of correlation, that we represent by the symbol called R, and this R value is between -1 to +1. So when we say coefficient of correlation gives you value between -1 to +1. So coefficient of correlation can be negative correlation, or the two variables can have positive correlation. Positive correlation means both the variables are going up or going down at the same time. Negative correlation means one is going up, another is going down, one is going down, another one is going up. That means they are negatively correlated. So basically, you can use scatter diagram to represent the relation between the two variable graphically. That part you can do. So a variance is the risk which is pertaining to one variable, and whenever you bring two variables or more than two variables in picture, then automatically the risk of individual variable will decrease, but the risk, a new risk will emerge, which talks about the mutual attraction or repulsion between the two variable, which we called as covariance. So when we say covariance, so if there's two variable x and y, so covariance between x and y, the two formula of that is summation of x minus x bar into y minus y bar divided by n. That is a one formula. The another formula is summation of xy by n minus x bar into y bar. This is the another formula of covariance between x and y. So you know the formula of covariance, and once you know the formula of covariance, you know the formula of variance. You know the formula of variance. So one formula of variance is summation of x square by n minus x bar square, and the another formula of covariance is summation of x minus x bar whole square by n. So if we use this formula together, so you know this is the formula of covariance, you know this is the formula of variance. Now if you bring them together into this relation, that you know the relation between two variables, that is covariance between x and y. Covariance between x and y is equal to r of xy into standard deviation of x into standard deviation of y. So I can find r value, r of xy value is equal to covariance between x and y. R of xy is equal to covariance between x and y into standard deviation of x into standard deviation of y. I can use this. So if I use this relationship, ultimately this is the relation between coefficient of correlation, covariance, and standard deviation. The same relationship you'll use in portfolio management chapter also. So by if you put all the values like the x and y values into this formula, ultimately you'll get the formula of coefficient of correlation, the formula which I discussed here. This was your formula 1 and this was the formula 2. All these formula you can derive by this. So let me talk about derivation, because the objective of me doing recording for this class is basically to discuss these two formulas, the two formulas of coefficient of correlation. So first, derivation of the formula rxy is equal to n summation of xy minus summation of x into summation of y divided by square root of n summation of x square minus summation of x whole square then n summation of y square minus summation of y whole square. So now this formula I want to derive. So how will I derive this formula? So if I talk about derivation of this formula, you know this formula. You know that r of xy is equal to covariance between x and y, covariance between x and y divided by standard deviation of x into standard deviation of y. You know this relation. Now, now talking further, what is the covariance between x and y? Covariance between x and y is equal to summation of xy by n minus x bar into y bar. Okay, so I can write this as summation of xy by n. X bar I can write summation of x by n. Y bar I can write as summation of y bar. Y bar I can write as summation of y by n. So ultimately, covariance between x and y, covariance between x and y, I can write a summation of xy by n minus summation of x into summation of y divided by n square. I can write divide by n square n summation of xy minus summation of x into summation of y. So ultimately, I think you got this. You understood this. Okay, so this is a formula of covariance between x and y. That is n summation of xy minus summation of x into summation of y by n square. You got this covariance formula between x and y. Similarly, when I talk about similarly when I talk about standard deviation of x, you know the formula, that is summation of x square by n minus x bar square. So standard deviation of x is equal to summation of x squared by n minus x bar. You can write summation of x by n whole square. So you can write this as standard deviation of x is equal to summation of x squared by n minus summation of x whole square by n square. You can, if you take LCM, you'll get n summation of x square minus summation of x whole square by n square. So if you can put that outside, so that is the standard deviation of x formula. Okay, so like the way I wrote standard deviation of x, I can write the standard deviation of y also. Like the same way, I can write the standard deviation of y also. Like the way I wrote the standard deviation of x, like the same way I can write the standard deviation of y also. Okay, everyone. So here I wrote the standard deviation of x is equal to n summation of x square minus summation of x ka whole square divided by n. Similarly, I can write standard deviation of y is equal to under root of n sum of y square minus sum of y ka whole square divided by n. This is standard deviation of y. Okay. Similarly, what I can do, similarly, can I do similarly, what is the covariance formula? So the covariance between x and y, I can write as I derive what I derived. I derived this. This is what I derived. So n summation of xy minus summation of x summation of y by n square. So covariance between x and y is equal to n summation of xy minus summation of x into summation of y divide by n square. Divide by n square. Divide summation and summation of y divide by n square. This I got for covariance. So now guys, I got this. This I got for covariance between x and y. This I got for covariance between x and y. Now this I got for standard deviation of x. This I got for standard deviation of y. If I put them into the relation, you know that r of xy is equal to covariance between x and y divided by standard deviation of x, standard deviation of y. If you put them into this relation, if you put them into that relation, so you know that r of xy is equal to covariance between x x and y divided by standard deviation of x by standard deviation of y. So you get n sum of xy minus summation of x summation of y by n square is equal to standard deviation of x. Standard deviation of x is so you know that 1 by n uh, n summation of x square minus summation of x whole square. Similarly, we can multiply with 1 by n, then it is n summation of y square minus summation of y whole square. So 1 by n, 1 by n, that is 1 by, that is n square. So this get cancelled. So ultimately, if you see this, ultimately if you see this is nothing but this is n summation of xy minus summation of x into summation of y divided by square root of n summation of x square minus summation of x whole square if you write them, and that is n summation of y square minus summation of y whole square. That gives you the formula of r of x. That is a one formula. The another formula is very easy to derive. Another formula, I don't think you'll find any difficulty in doing that. Deriving another formula is very easy. So another formula of r of xy was summation of x minus x bar into y minus y bar divided by square root of summation of x minus x bar whole square summation of y minus y bar whole square. You know this is another formula of r of xy. Now you know the relation that r of xy is equal to covariance between xy. R of xy is covariance between x and y divided by standard deviation of x into standard deviation of y. Okay, you know this relation. I think from beginning of the class I'm talking about this relation. Now, there's a formula of covariance. I told you the formula of covariance. I told you that is covariance formula is summation of x minus x bar into y minus y bar by n. This is the formula of covariance. I told you. This is the covariance of xy, you know, summation of x minus x bar into y minus y bar by n. Similarly, the standard deviation of x is under root of summation of x minus x bar whole square by n. Similarly, you can write standard deviation of y as summation of y minus y bar whole square by n. Now, if you put all of them into this formula, r is equal to covariance between x and y divided by standard deviation of x by standard deviation of y. So, if you put them into this formula, r of xy, so that is covariance between x and y, that is summation of x minus x bar into y minus y bar by n. This divide by standard deviation formula is the square root of summation of x minus x bar whole square by n into the summation of y minus y bar whole square by n. So ultimately, if you do this, you'll get summation of x minus x bar into y minus y bar by n divided by square root of summation of x minus x bar whole square summation of y minus y bar whole square divided by n square. So under root of n square, you know that is n. So this is summation of x minus x bar into y minus y bar by n. So this will give you square root of summation of x minus x bar whole square summation of y minus y bar whole square by n. So n and n you can cancel. So ultimately you'll get the formula which I told you, r of xy is equal to summation of x minus x bar into y minus y bar divided by square root of summation of x minus x bar whole square summation of y minus y bar summation of y minus y bar whole square. So that's much. So The purpose of this class was to discuss the two formulas, the derivation of these two formulas. I hope you understood this. So that was the intention of doing this class. So with this, I'll wind up the class. So if you like the class, please don't forget to click on the like button. And if you're not subscribed to my channel, feel free to subscribe my channel and get all the updates related to business statistics, which is relevant for your MBA curriculum. Thank you, everyone. God bless you.